I'm Erika. Let's do some GMAT work rate questions. It's no secret that word problems are not a fan favorite GMAT Quant question type. And it's really not a secret that work rate is a particularly challenging type of GMAT word problem. But GMAT work rate questions are a lot more bark than they are bite. You can solve any problem with just two equations, and almost all problems lend themselves to one user-friendly problem-solving approach. In this video, we're going to work through 3 levels of GMAT work rate questions. One easy question, one medium question, and one hard question, where the hard question is particularly nasty, stumping 60% of target test prep GMAT students. But we're going to solve all 3 questions with the same approach and the same 2 equations. Before we jump in, make sure to ring the notification bell for new videos from me every Wednesday. We'll start with the easy question to introduce our approach to work rate and our 2 work rate equations. If you want to try this problem on your own, you can pause the video here because I'm going to jump right in. So this is the stereotypical work rate problem setup. We've got 2 hoses working together to fill a pool with water. So we should be able to identify it as a work rate problem almost immediately. Now, once we know that this is a work rate problem, we know that we'll be working with the first of our work rate equations, W equals RT, or work equals rate times time. Now, if you're familiar with distance rate problems, you know the corresponding equation, distance equals rate times time, or D equals RT, which many test takers remember as DIRT. Well, I like to think of this equation as WORT. Now, this equation is the foundation for our problem-solving approach, which is to create a table or a matrix for the different ways in which work is performed in the problem. So I'm going to go ahead and make a column for each of these variables. And now as I read the question stem, I'm going to create rows for the different ways in which work is performed, filling in the cells as I go. Okay, starting with the first sentence, the hose at the front of the house can fill the pool in 10 hours. Okay, this is going to be my first row. I'm going to call it F for the front of the house. Now, I know that it fills the pool in 10 hours, so 10 is obviously my time, but what else can I fill in? Well, hose F fills one entire pool. So that is the work being accomplished. One pool. Okay, let's move on to our second sentence. The hose at the back of the house can fill the pool in 6 hours. Okay, new row. Calling this B for back of the house. So once again, our work is going to be one pool, and the time this time is 6 hours. All right, moving on to our last sentence. If both hoses were used together, how long would it take to fill 4/5 of the pool? Okay, now here we are going to have our third row for the hoses together, front and back, or F and B. Okay, now note here, we are not filling one whole pool. We are filling 4/5 of the pool. And we are trying to find how long would it take. So we are solving for the time. I'm going to go ahead and mark that on my matrix so I solve for the right thing. All right, so I've processed my question stem. Where do I go from here? This is where the matrix is going to start to come into play. We can see that in the F and B rows, I have 2 out of the 3 cells filled in, or I know 2 of the 3 variables, W and T, work and time. This means that I can solve for the third cell, or the variable for rate in each one. Okay, I'm going to go ahead and do that for the front of house hose. All right, pulling the equation out, I see that my work 1 is equal to rate unknown times time, which is 10. Okay, dividing both sides by 10, I get that R is equal to 1/10, filling that in my matrix. Okay, moving on to my second row. Again, I have work is 1, rate is unknown, times time 6, dividing both sides by 6, I get that rate is equal to 1/6, filling that in. Now, note that because work was 1 in both of those rows, the rate is just the reciprocal of the time. And so that means that we probably could have just done this with mental math, and that's totally fine. But know that you can write things out whenever it helps you. So especially if you have more complicated math. So if work, for instance, is not 1. You may want to write stuff out outside of your matrix to manipulate. Okay, so we filled in our first 2 rows, but our last row only has 1 cell filled in, so we can't solve as is. So where do we go next? This is where we're going to utilize our second work rate equation, or our combined rate equation. And that's going to be the rate of A plus the rate of B equals the rate of A and B. Okay, so what does this mean? Our second work rate equation is based on the principle that rates are additive. When 2 workers work together, their respective rates can be added to get their combined rate. So if we, for instance, have 2 workers, A and B, we can add the rate of A working independently to the rate of B working independently to get the rate of A and B working together. Now, notably, this also holds true when workers are working against each other or in opposition to each other, except that one rate will be negative to represent working in the opposite direction. But that is not relevant to this problem. We have things working together. So now applying this equation to our problem, we have the rate of hose F working independently and the rate of hose B working independently. This means that we can add down the rate column to get the rate of hoses F and B working together. So 1 over 10 plus 1 over 6. We're going to need a common denominator. So multiplying by 3 over 3 here to get 3 over 30. Multiplying by 5 over 5 here to get 5 over 30. Adding that together for 8 over 30, which reduces to 4 over 15. Okay, now that we know our combined rate for hoses F and B is 4/15, we have 2 cells in our final row, meaning we can solve for the third. Okay, pulling this out of the matrix so we can manipulate. Our work is 4/5. It equals the rate, 4/15, times our time, which we do not know. All right, manipulating, we are going to multiply by the reciprocal of 4/15 in order to divide by 4/15. That is going to cancel on the right side. On the left side, the 4's cancel. We're going to pull a 5 out of that 15th, leaving us with a 3. So 3 equals T. We can fill that in our matrix, and we see that it will take 3 hours for hoses F and B, or the front and back of house hoses combined, to fill 4/5 of the pool. So our correct answer is B. Now that we're warmed up, let's attack the medium difficulty question. This question trips up twice as many target test prep students as the last one, and I've tweaked it to make it slightly more challenging. Okay, once again, feel free to pause if you want to try this one on your own. Okay, like the last question, we've got something being accomplished, in this case, a desk being built in some amount of time. That is a work rate question. So I'm going to go ahead and start building out my work rate matrix. And while we do that, we're going to go ahead and notice something else about this problem. And that is that there are no numbers in it. There are letters or variables. And that means that the answer choices are expressions composed of those variables rather than numbers themselves. Now, taking a problem from arithmetic to algebra is a classic move to level up the difficulty of a problem. Now, there are a couple of ways that we can handle this. We're going to start with kind of the more straightforward option, and then we'll explore a different option, but both are going to use our matrix approach. Okay, let's break down our question stem just like last time. Okay, Paul can build a desk in X hours. All right, we're going to start our first row for P for Paul. All right, once again, our work is 1, but instead of 1 pool, it is 1 desk. But now our time is X hours, so filling in our variable instead of a number. Next sentence, when Paul works with his brother, the 2 of them can build a desk in Y hours. Okay, interesting. So instead of giving us an individual rate, perhaps the rate of his brother, this sentence is giving us the combined rate of Paul and his brother. I'm going to go ahead and give myself some space in the matrix because I think I can see where this problem's going. And I'm going to make a row for P and B, or Paul and we know they can build one desk in Y hours. Okay, last sentence. How long would it take Paul's brother to build a desk by himself? Okay, so as predicted, we are going to be creating another row for Paul's brother by himself. So we're going to put B here for brother. And we know that we want him to build one desk all by himself. And we want to know how long is it going to take, or what is the time for Paul working by himself. So we've actually got a pretty similar setup to last time. We've got 2 rows with 2 cells filled in and 1 row with just 1 cell filled in. And we're trying to solve for a value in that row. Now, it is a different row, right? Different rows have different amounts of information, and that information is largely in letters instead of numbers, but that doesn't impact the next step. We're going to go ahead and start filling in the other cells in our matrix. Okay, so first row, work is 1 and time is X. I'm going to go ahead and do this one in my head to get that rate is 1 over X, or the inverse reciprocal of time. Now, it's totally fine to write this out if it helps you feel more confident in your math. Okay, we're going to go ahead and skip the second row since we only have the 1 cell, and we're going to move on to our third row. Work is 1 and time is Y, so the rate is going to be 1 over Y. All right, let's look at our rate column. Now, last time we were able to add our 2 individual rates to get our combined rate. Here we have our combined rate and 1 individual rate. Can we still use our combined rate equation to find our other individual rate? Well, yes, we can. We're just going to have to manipulate it a bit. So we're going to pull the equation out of the matrix to make that easier. So we have 1 over X plus our unknown rate of B equals 1 over Y, or our combined rate. Okay, manipulating that a bit, we're going to have rate of B, or of the brother, equals 1 over Y minus 1 over X. All right, finding a common denominator, we're going to multiply this fraction by X over X, multiply this fraction by Y over Y, and that is going to give us that the rate of the brother is X minus Y over X, Y. And hey, that's answer choice C. Is that our answer? Be extremely careful here, because what did we just solve for? We solved for the brother's rate. We want the brother's time. All right, now this is a classic answer trap. If you've seen my video on 7 mistakes you cannot make if you want a high score, you know that most students get questions wrong in the first 30 seconds of the problem or the last 5 seconds of the problem. And intermediate solution answer traps like this one are the prototypical example of tripping at the finish line. So this is why we want to be sure that we set ourselves up for success by intentionally and visibly noting in our work what exactly we're solving for, and then checking back before submitting our answer to make sure that we did in fact solve for the right thing. Okay, now that we have narrowly avoided solving for the wrong thing, let's go ahead and finish solving for the right thing. All right, we have the work and the rate in row B. We can solve for the time in row B. Now, if we had more complicated math, we could write this out over here and manipulate, but because we know that work is 1, we know that time is going to have to be the inverse or the reciprocal of rate. So time is going to be X times Y over X minus Y, or answer choice A. Now, what if we'd prefer to avoid algebra? Like I mentioned, there is another way to solve this one, which is the strategy of picking numbers. So we're going to pick simple numbers to replace X and Y with, and we're going to solve the problem with those numbers instead of with variables. So I'm going to go ahead and choose numbers 5 for X and 2 for Y. Now, notice here that I am choosing a smaller number for Y than for X because Y is the amount of time that it takes both Paul and his brother to build the desk together. They should build the desk faster working together. The math is going to get kind of nasty and not work very well if you don't do this. So make sure that you are choosing logical numbers. Okay, now that I have my numbers picked, I'm going to go ahead and fill in my matrix using those numbers. So Paul can build a desk in X hours, one desk in X equals 5 hours. Okay, when Paul works with his brother together, the two of them can build a desk in Y hours. Okay, so together they can build one desk in Y equals 2 hours. How long would it take Paul's brother to build one desk by himself? Once again, solving for time. Okay, now we can go ahead and solve for rate in our two rows where we have two cells filled in. So rate is going to be 1/5 here. Rate is going to be 1/2 here. All right, now we can use our combined rate equation. 1/5 plus the rate of the brother equals 1/2. Rearranging, rate of brother equals 1/2 minus 1/5. Finding a common denominator, we are going to get 5/10 minus 2/10, or 3/10. Filling that in right here. Okay, so once again, 1 equals our rate times our time. Our time is going to have to be the inverse of our rate. So here, the inverse of 3/10, or the reciprocal of 3/10, is 10/10. Okay, moving on to our answer choices. Now we know that if we plug the numbers that we picked, so 5 and 2, into our answer choices, the correct answer should give us 10/3. Now, we could just start plugging numbers in and going through our answer choices one by one, but we can also just look at the answer choices and see which ones make sense. So, for instance, if we look at B, that's going to give us a whole number, obviously, so that's not going to be 10/3. D is going to have a 1 in the numerator. Looking at our remaining answer choices, 2 of them have X times Y, or 5 times 2, 10 in the numerator. So those make sense, but C does not. That's going to have a 3 in the numerator. And then taking a look at our denominators, this one's going to give us 3. This one's going to give us 7. So the only answer choice that gives us 10/3 is answer choice A, which is our correct answer. Time for the hard question. Like I mentioned before, this one is a doozy, with 60% of Target Test Prep GMAT students getting it wrong. Now, I've adjusted it slightly for the purposes of this video, but it's still very, very hard. All right, last one. You know the drill. Feel free to pause the video if you want to try this one on your own. All right, this one literally has the word work in the first sentence. So we're going to go ahead and build our work matrix. Okay, so the first sentence tells us that Padma, Miles, and Troy work at their respective constant rates. That doesn't tell us that much other than that we can assume that the individual rates for each of these people is not going to change. Great. All right, next sentence. Working simultaneously, Padma and Miles can cook a meal in 3/4 of an hour. Okay, so this is interesting. So instead of giving us an individual rate in this sentence, we are getting a combined rate. So P and M for Padma and Miles can cook one meal in 3/4 of an hour. All right, Padma and Troy, working simultaneously, can cook the same meal in 1 hour. All right, so we are getting another combined rate. Padma and Troy, P and T, can cook one meal in 1 hour. Okay. Miles and Troy, working simultaneously, can cook the same meal in 4/5 of an hour. All right, so we have yet another combined rate, M and T, one meal, 4/5 of an hour. All right, working simultaneously, once again, how many meals can Padma, Miles, and Troy cook in one day? Okay, so we are being asked for another combined rate. Gonna give myself some space here because I'm not entirely sure what I'm gonna do here. We're getting P and M and T. And we want to know how many meals or how much work can be accomplished in one day, or changing it to our unit used in our other times, 24 hours. All right, so this is pretty clearly a more difficult question. In the previous questions, our scenario involved 2 individual rates and 1 combined rate. Here, our scenario involves 4 different combined rates composed of 3 individual rates that we don't know any of. So at this point, we may not see the path all the way to the answer, but that's okay, because at least the next step is pretty clear. Let's get each of the 2-person combined rates. Work for all of these is 1, which makes our math a little simpler. Rate is simply going to be the reciprocal or the inverse of time. So for P and M, the rate is going to be 4/3. For P and T, the rate is just going to be 1. And for M and T, the rate is going to be 5/4. Okay, so where do we go from here? Well, we essentially have 3 different combined rate equations, 1 for each of these 2-person rows. So in our first row, we have the rate of P plus the rate of M, and that is going to equal 4/3. In our second row, we have the rate of P plus the rate of T, and that is going to equal 1. In our third row, we have the rate of M plus the rate of T, and that is going to equal 5/4. Now, at this point, you might be thinking, hey, I've got 3 equations, and in those 3 equations, I have 3 variables. This is a system of equations. I can use substitution or elimination to solve for each of those variables individually, to solve for each of my individual rates. And then I can add those individual rates. So I can add the rate of P to the rate of M to the rate of T. And then that is going to give me my combined rate. I can plug that into my matrix, and I can use it to solve for my work. And, in theory, that could work. But let's take a moment to pause. If you've seen my video on 6 strategies that do not work, you know that quant problems aren't really testing math. They're using math as a scaffold to test critical thinking. Now, this path to the answer sounds like a lot of math, a lot of time-consuming, error-prone math. But it doesn't sound like a lot of critical thinking. So let's try thinking critically. Is there another way to get what we're solving for? Now, notably, we're not solving for the individual rates. We're solving for the 3-person combined rate. Is there any way that we can get directly to that 3-person combined rate using our 2-person combined rates? So what if we did what we did in the first problem and just added the rates that we have together? Let's see what that would give us. So adding these together, we're going to see that we have 2 rate of P plus 2 rate of M plus 2 rate of T. And that's going to give us something. We're not going to solve for it yet. But if we pull the 2 out of this expression, we get 2 times rate of P plus rate of M plus rate of T. Now, hang on. This expression that's in our parentheses is the exact same thing as our 3-person combined rate. So if we add our 3 2-person combined rates together, all we have to do is divide by 2, and it'll give us our 3-person combined rate. This is a classic systems of equations trick. Sometimes there is a third move beyond substitution or elimination. All right, so to add these up, we're going to want to get a common denominator. So multiplying by 4/4 here is going to give us 16/12. Multiplying by 12/12 here is going to give us 12/12. And then multiplying by 3/3 here is going to give us 15/12. Adding those up, we are going to get 43/12. All right, now be so careful here. A classic mistake would be to use this as our 3-person rate, but it is not our 3-person rate. It is 2 times our 3-person rate. We need to divide both sides by 2, giving us 43/24 as our 3-person combined rate. Plugging this into our matrix, we start to see that this math is going to come out really clean. Work is equal to rate times time. Our rate is 43 over 24. Our time is 24. Those 24s are going to cancel out beautifully to give us a work of 43 meals in one day, or answer choice D. Now, of course, these are just 3 example questions. There are a lot of other work rate question variants that you could see on test day. Questions where work is completed in multiple stages. Questions with opposing workers, questions with multiple identical workers, questions where rates are given relative to other rates, and so on. So it's worth continuing your practice beyond this video to familiarize yourself with the various forms that work rate questions can take. But whatever spin the test puts on them, work rate questions come down to the same basic principles: knowing and applying 2 simple equations and taking an organized approach to your problem solving. If you like the 3 levels format of this video, give it a thumbs up to let us know we should make more like it. And if there's a specific question type you'd like me to make a 3 levels video about, let us know in the comments. Thanks for watching, and I'll see you guys in the next one.